A function does not have a derivative or is not differentiable if. Anyone, please. Anyone?
If it's not continuous.
Good. Excellent. So I see somebody with an iPhone. I will not be able to give you credit for attendance because I don't know what iPhone means. Okay. What else?
You said what? I'm sorry. This is my
It's not you. It's not you. It's somebody else, and I see iPhone. And I
Oh,
will.
okay, yeah. That's why I changed my display name. Sorry.
No, it's not you. Oh, it is you. Okay, got it. Good. And
If it has a cusp, corner, or a vertical tangent.
thank you. Please remember that. Awesome. The definition of the derivative has concepts. Has what? The definition of the derivative has, I'm missing something here.
Was it two concepts?
Absolutely. And they are?
Limits and difference function.
Very good. So please remember, you will be given a function and you will be asked to use the definition of the derivative, not differentiation rules, the definition of the derivative to determine f prime. Good, awesome. What about this rule? X to the nth power prime. Can anyone give us that rule? Anyone? Can anyone give us this rule?
X times n times 1.
Bring down n times x to which power?
N minus 1.
Thank you very much. What about 1 over x prime? What would that equal to?
0.
Careful. Okay, I forgot to put that in. A constant prime. How much is a constant prime? The rate of change of a constant.
Zero.
Thank you very much. Again, we are back here. 1 over x prime.
Negative 1 over x squared.
Thank you very much. Negative 1 over x prime.
One over x squared.
Thank you very much. What about f of x plus or minus g of x prime? Joan, what do you think?
Prime.
Yes? Erica, go ahead.
Is it f prime plus g prime?
And if it's minus, it's minus. Good. Awesome. Final question here before we start. Explain the sentence. Find the rate of change of f of x. What does that mean? What do you think we're asked to find? And I will put it in.
The amount it has moved, or the amount it has increased or decreased.
We're not there yet. That will be in chapter 3. I promise you, those are applications of differentiation. Awesome. So if a function is increasing or decreasing, it has to do with the derivative, and this is in chapter 3, and these are applications of differentiation. I promise you we're going to get to that. So before that, find the rate of change of f of x. If I ask you, I'm giving you, let's say, f of x equals x squared plus 1. And I'm saying to you, and I'm asking you to find the rate of change of this function. What am I really asking you to find?
The slope.
Close. Somebody else tried something. Yes, Natalie, go ahead.
Is it f prime of x?
Fine, thank you very much. Exactly. This is exactly what it means. Thank you. So let's go back here. That's how we started. Find the rate of change of a function. In other words, I said, no, we're not going to write that again, or we may ask you like that, but we are really asking, find the rate of change of the function? No. That means find f prime. Thank you. So please remember that. Good. So now the floor is open for questions. If no questions, we continue. Anyone? Any questions? Did you encounter any difficulties in Pearson or anything that you worked on? Anything?
I just had the one question.
Yes, I'm ready. Oh, yes, yes, yes. I have it written down. I wrote it down. Thank you so much for reminding me. I have it in my notes right here. It was the square root of 2x plus 10. Okay, excellent. Thank you for reminding me. So the question here is to find the difference quotient for this function. Can anyone give us the difference quotient again? In general, the formula for the difference quotient.
F parenthesis x plus h.
Yes, we say f of x plus h. It's not a mistake to say f parentheses, but we really mean f of x plus h.
Okay. So would I say minus f of x?
Exactly. Awesome. Divided by h. So we want to find the difference quotient for this function. Of course, this is it. There is nothing I can do. This is it. There is nothing I can do to it. It's this piece. So I have to start with here. That's my starting point. Good. Can anyone tell us what to write? I need to identify this and put it here. Can anyone give it a shot? What should I write in there?
Is it square root 2 times x plus h?
So I'm assuming you meant parentheses. Awesome. Yes.
Yeah, sorry.
Plus 10. Brilliant. That's it. Awesome. Now the next step must be to distribute in here. And then we'll decide what to do next. So I have the square root of 2x plus 2h plus 10 minus the square root of 2x plus 10 divided by h. Now there is a procedure. I think we talked about it. I'm pretty sure we did. I remember writing it. I'm going to write it again. Rationalizing the numerator. What do I rationalize the numerator by? Remember, this piece has to equal 1, because I cannot change this. But if I multiply by 1, there will be no change. Can anyone tell us how we rationalize this?
Would you just multiply by square root of 2x plus 2h plus 10?
So remember, good question. So remember what we talked about the first day of classes. we had three formulas, also called special products. So what you're saying is good, but for something like this, with one term, then you multiply by the square root of x and divide by the square root of x, and you get the square root of x over x to rationalize the denominator. But if I have, like we have here, the square root of a minus the square root of b over h, I cannot use one term because I have two radicals. So I have to use the special product, which is the square root of a plus the square root of b over the square root of a plus the square root of b, because it has two terms. Otherwise, I would have used this procedure, but because this one it has one term. But because it has two terms, I have to use those formulas, specifically the difference of squares. And that's how I get at the top a minus b, and the denominator is this. So again, we have two terms. Multiplying by one or the other is not going to remove the radicals at the top. I have to use this special product. So let's try again. What do we multiply and divide by? I would like to hear from everyone. It will help you and it will help me to find out what I need to emphasize. So can I hear, let's say, from Devin? I haven't heard from Devin, or Sam McLean, or Carmen. I don't know if I heard from them. It's okay if you're wrong, but you see the formula here, right?
Would it be the square root of 2x plus 2h plus 10 minus
Careful.
the square root?
Careful. This is very important.
Would it be plus?
Exactly. Exactly.
Of 2x plus 10?
Yes, and the denominator has to be identical. Yes, it has to be identical because this has to be 1. You understand that since these are the same, this fraction is 1. Good. Of course, you know me. I don't want to copy, not because I'm lazy, but I just don't want to waste time. So the denominator is h, the square root of 2x plus 2h plus 10 plus the square root of 2x plus 10. Now, can anyone give us the numerator? And look here, the result. Can anyone multiply this by this and tell us what to write at the top?
Yes. 2x
Yes?
plus 2h plus 10 minus 2x plus 10.
Careful, you either say parentheses because there are two terms. You cannot just distribute to one of them.
Oh, I'm sorry, minus 10.
Exactly. Now I'm going to ask you, when we talk about the difference quotient, what are the two things that have to happen? What has to happen next? Anyone? Yes?
We cancel out the top, so we only have to...
We have to cancel what? Not the top. We have to cancel what?
The x term.
Like terms?
The terms without h. If the terms without h don't go away, we will not be able to clear this one eventually. So the terms without h, they do go away. That's why I'm begging my students to watch the videos, because this will become ingrained in your system if you hear this several times. So 2h divided by h, the square root of 2x plus 2x, I meant plus 2h, plus 10 plus the square root of 2x plus 10. Good. What is the second thing that has to happen? If it doesn't happen, we know there is a terrible mistake somewhere.
Cancel out the h's.
Exactly. They cancel out because all the terms without h went away. If the terms without h don't go away, you will never get to this step. So then the final simplified form for the difference quotient for the given function, it's an ugly function, but that's what it is. Good. Anything else for me? Other questions, please? Anything?